graph, this is a pre-calculus lesson. Hopefully it's just review, so the pace will be accordingly. It should be stuff you know, it's just kind of an extra reinforcement, hopefully. So, the very end we're going to do later. So I got this graph, this is F, okay? It's two semicircles and a line segment, and later on when we do fundamental theorem, we'll use graphs like this. For now, it's just a funky graph, all right? The idea is we're going to talk about all the different ways to change a graph. Stretching, shifting, reflecting, all that good stuff. Hopefully that's review. But let's start here. I want to make sure that when things get funky and complicated, that you know you always have a backup. And you don't have to say, oh, geez, I can't do it. There's always the backup of, I guess I can always make a table and graph it that way. Now, that's the worst way. It's the least efficient way, but it's better than throwing your hands up and saying, I quit. So towards that end, if I told you g of x was some function that took absolute value and added 1 and subtracted 2 and negated, that's a bit of a mess. And it would be hard to decipher all those changes and the order in which those changes match. So that's complicated. But keep in mind that you can always do a table. So, for example, if I asked you what is g at -4, then I could say, well, g at -4 is the same as 2 minus f of the absolute value of -4 plus 1. And what is the absolute value of -4 plus 1? 3. And what's the absolute, -3, and what's the absolute value of that? 3. And so now, to the graph we go. What is f of 3? -3. So we get 2 minus -3. So in the end result, g, whatever it looks like, would have a point of -4. Are you with me? Try the next one on your own. What'd you get? -1, yeah, because -1 plus 1 is 0. F at 0 is 3, according to the graph, and 2 minus 3 is -1. Are we down? Okay. If you did -1 there, it sounds like most of you got -1, so it feels like you understand. Let's move on, shall we? Okay. Now let's talk transforming a graph. When you add to x, it is logical that you're going to change x, and therefore change the graph in a horizontal fashion or vertical fashion? Horizontal. You change x, so you're going to change the horizontal. Shifting, how does it work? Does that mean it's right one or left one? Left one. That to me always pooped me out. That's totally counterintuitive. I think you'll agree, yeah? And yet, this is what a teacher helped me with. He said, okay, when is that at its least? What's the least a square can be? 0, okay? So that's why the minimum is where it is. What about this then? Don't focus so much on here. Focus on what x is. What makes that 0? -1. So it's not so much what's here, it's what x has to do to compensate for that. And that's why it's a leftward shift. Okay, so it's left, which means that first point on the far left. What's the far left point? -5, -1, yes? What about this point where the x-intercept happens? Instead of being at -3, 0, now it'll be at -4, 0. And what about the y-intercept? It won't be the y-intercept anymore. Where will that y-intercept point be shifted to? -1, 3. So we've got two semicircles there. And where will the line terminate? To -3. Okay, so boom. What about if you add one outside the function. Well, the function is y. So if you add one to the function, you're changing y. So how will it shift? Up. Okay, now this one actually makes sense. Whatever the y is, calculate it first, then add 1. So up 1. Would you give that a quick sketch then? 0. Da, da, da. 2, 3, 4. And 3 negative 2. And my semicircles don't work. Quarter circles don't work. It's up 1. Okay? Okay. What just changed? The domain or the range? The range. Okay, let's go to this. Multiplying by a factor causes a stretch or a squish, which is not a mathematical word. Compression perhaps would be a better word, but squish makes sense to me. If, again, the idea is if you change x, then you're changing the graph horizontally. So when I take that first one and multiply by a factor of 2, surely it's a horizontal change, either a stretch or a squish. Which is it, a horizontal stretch or a horizontal squish? Squish. If you remember that, great. If you're not clear on that, remember a sinusoid. Sine of x normally has a period of 2 pi, but when you condense it, everything happens as fast, and now it has a period of pi. So this will be a squish. Okay, so great. Where does that first point happen? That leftmost point. What's the leftmost point now? Negative 2, and will the y change, or will the y stay negative 1? Negative 1, okay. What about this guy here? It was at negative 3. Now what will it be at? Negative 1.5. And what happens when you half the y-intercept of 0? Well, nothing. It's half of 0 is still 0. So it's like that. What about the far right point? Instead of being at 3, negative 3, it'll now be at 1.5, negative 3. The y doesn't change. All right, so horizontal compression. Cool. So then what will dividing x by 2 do? Yeah, it'll be a horizontal stretch. And so, will you just tell me this? What will the domain be? Negative 8 to 6, yeah. Do you want to grab that, or let's move on? Okay, let's move on. All right. What about multiplying outside? When I take a sinusoid, normally the amplitude is 1 going up from the center line 0. It will go up 1, down 1. Tell me, we know sine is less than 1 or equal to 1. Why? That's math, that's it. You know what? Can't be 1. Tell me why sine can't be 1. What is sine? What is sine? What is sine? Sine of an angle is the ratio of the opposite side to the hypotenuse, yeah? So, again, why must that be less than or equal to 1? Because in a right triangle, the hypotenuse has to be bigger, or even if they're straight on top of each other, equal. So, okay. So back to this then. Sorry, I often go on tangents. Help joke. That's a stretch of 2, so vertically. So what about that leftmost point? Where will it be now? Negative 4, negative 2. The y will change. What about the place where y was 0? It was at negative 3, 0, and now it'll be at negative 3, 0. What about the place where x was 0, y was 3? Now it'll be at 0, 6. And what about that far right point? What will it change to? 3, negative 6. Okay, cool. And then, so what will that do? This is vertical stretch. What will dividing by 2 do to f? Vertical stretch. Okay. All right, cool. What about reflection? If the negative falls on the x, what happens to the graph? Flips over the x-axis or the y-axis? The y-axis, okay? Here's positive x's and here's negative x's. If we exchange them, then we're going to reflect over the y-axis. Now, I know that's, again, sort of counterintuitive on the surface level, but if you think about it, changing x's to negative x's is flip over the y-axis. Reflect over the y-axis. So take a second to doodle that, and I will do the same, and then we'll compare. Oops, I just reflected over the x-axis. You agree with that? Cool. What about a negative outside? That's changing the sign of y. Well, if you change the sign of y, or f, from positive f to negative f, then we're going to flip over the x-axis. And so we would have, you get the idea, 3, negative 3, or 3, negative 3 would become 3, 3. 0, negative 3 would become 0, 3. The 0 would be unchanged, and so you would something like that. Cool. All right. Absolute value. One of these is easy, one of these not so easy. Let's do the second one. This, what is it taking the absolute value of? X's or Y's? Y's. Okay, so let's think about that. When Y is positive, what does the absolute value do? What happens when you take the absolute value of a positive? There's no change, okay? So anywhere Y is positive, there will be no change. What about when Y is negative? What does the absolute value do? It makes it positive, makes positive Y's. All right? So let's look at this graph here. In this region here, Y's were already positive. So if I take all those numbers and throw absolute value on them, what happens to them? They stay exactly the same. So the part of the graph from negative 3 to 0 to 1.5 is unchanged. But this guy, if I track this point, let's say I put negative 4 into this guy. F of negative 4 wanted to be negative 1, but then I take the absolute value of that, and now it's made positive 1. And so that point that was below is now above. And these guys, for example, here, when I put in a 3, f of 3 is negative 3, but then take the absolute value of that, it's made 3. And so all the negative parts get flipped up. Parts below the x-axis get flipped up. Now that's pretty easy. Usually students do well with that, but then students tend to want to carry it through to the next idea. This one's a little more difficult here. Let's use the same concept though. When x is positive, what does the absolute value do? Nothing. It has no effect. I can ignore it. So when x is positive, no change to the graph. Now let's do that part first then. So what part of the graph will be exactly the same? From 0 to 3. So the whole right side of the graph, no change. And all those points on the absolute value didn't change the sign of x, no big deal. But for the negative side, let's see what happens. When I put in negative 4 here, when I do the absolute value first, So it's the absolute value of negative 4. 4. And what's f of 4? F of 4 is non-existent. I don't have anything f of 4. So I don't know what to do there. In fact, I could try negative 3. Now again, I'm feeling like, where is this? What's happening here? I'm not seeing this. What's going on? Let's try negative 3. What's the absolute value of negative 3? 3. And what's f of 3? Negative 3. So instead of this point happening, when I put in negative 3, I actually get a point just like f of positive 3. And if I were to put in, for this, I know it's gross to feel like it, but if I were to put negative 1.5 in, what's absolute value of negative 1.5? 1.5. And what's f of 1.5? 0. And so what happens to the graph is the right side, which is the left side, where negative x happens, is a mirror image of positive x. Well, what happens to the semicircles? Well, they never happen. They're gone. All right. I'm going to leave the rest of, bless you, I'm going to do the rest of, that's a really good in-class activity, and I love the discussions that happen, but I don't have time for a particular quiz. So we're going to bypass that and maybe come back to it Monday. Okay? So that'll be the end of that. How is the old homework going, my young pupils? Is it a struggle and frustration, or no big deal? No big deal. I love that you use the same question. So we're looking at 20 to 21. I've had a couple questions over and over the last couple of days, but I'll be happy to go over any one. Would you just give me 20 number this or 21 number that? Do you have any questions?
21 number 1.
21 number 1. I'm going to write these down. Why don't you give me anything you got right now so I don't have to. 21 1. Anything else? What's that one? 26. Some people ask about 20.7, 20 number 7, but maybe that was, I've already done all that. Okay? All right, so 21 1 is the only one I hear so far.
26.
20 number 6? Okay. 20 number 7, okay.
20 number 16.
20 number 16. Okay? Feel free to add to that list later. In terms of what I expect and how I work here, if I'm working on those questions and you already asked about this before school, or you've got that, no problem. I'm not going to be insulted if you're not paying attention to a question that you already know how to do. That doesn't make a difference. It's probably a waste of your time. Now, if we go off on a tangent, I'm going to have to stop saying it, and start discussing something else, well, then maybe you should put that. But if you're working on your homework from my class for tonight, while we're doing a problem fine. I do take offensive while I'm working here, you're doing your physics. Okay? All right, 21-1, here we go. As always, I'll remind you, as old students, the goal is to learn. So if my explanation stinks, then it's on you to say, I don't get this. Those are the students I respect most. I don't think they're a pain in this. Keep saying that. What? Why? That's a good student. That's a critical thinker. Also, just so we're clear, when we go over questions in my class, it's not copy fest. It's we're working together to clarify the misconceptions. So the point I guess I could summarize it is be actively engaged. Number 1. All right, this is a great question. Now, this is meant to set the stage for optimization. I'm so glad you asked this question because it's not, technically, it's not really anything you've ever learned. It's a pre-calculus concept that we didn't actually teach in pre-calculus, so good question. The idea is you got this wall, maybe think of it as your house, and you're going to make an enclosure, like a dog run off of it. Rather than build it off into the space and have to include all 4 sides, we're going to make this fence off of the house, so we only have to do 3 sides, which allows us to make it a little bigger, okay? But it probably makes the house look trashy, but whatever. So the idea is you've got 100 meters of fence to work with, and I'll kind of set the stage for the calculus of it. There are a lot of different situations or scenarios for how I could make the fence. I could do a kind of square one and use 100 that way, or I can make it really long, or I can make it really fat. And they would, or somewhere in between. Now, all of those have different areas. And so the question of calculus is, which is the best one? Which one should you use? They're different. Well, that's called an optimization problem. Now, before you can do the calculus of it, you have to be able to actually get an equation to do calculus on. That's what this question is. What's the equation? Yeah. The whole goal is to get an area equation. Now, they said call this L, no matter which of the scenarios are. And I guess by default, I'll call this W. And wouldn't you agree that the area of that is length times width? Oui. Now, the second part of the question then is, make it in terms of L only. Now, the reason you want to do that in calculus or calculator is you can't put 3 variables into your calculator. You can put it 2. Or you can't, it's harder to do calculus with 3 variables. It's easier to do 2. So you want to get rid of one of these variables and make it just 2. Now, this is the one we want to get rid of, so it's all L terms. To do that, I need to sub in for W with some kind of fact. To do that, I need to ask myself, is there some other info relating L and W given? And they will have to give you something. What's another relationship between them besides the area? Read the problem. Don't let it's on my face. Well, perimeter. Yeah, there's a limitation that we only have 100 meters of fence to work with. So if I use that idea, what's an equation that relates WL and the 100? How do you put those together? Somebody, yeah?
Plus 2W.
Beautiful. All right, so now the question is, I want in the end to get this with L's only. So what should I solve this for? Yeah, if I solve it for L, wouldn't that be W-ish? And when I put that in, I have all W's. I want to solve it for W. So what is W? 100 minus 2 L, or 100 minus L, yeah. 100 minus L over 2, yeah? Stop me if you disagree or if I made a mistake or you don't see where that's coming from. All right. So now if I substitute that in, A is L times 100 minus L over 2. Are we good? And that answers the question. Now, just because I'm a total nerd, I want to go further. You can actually answer this question with pre-calculus. I know that graph looks funny, but what kind of graph is it? Think negative L squared. It's a parabola, opening up or down? Down. What are the zeros? Factored form allows you to find zeros. What are the zeros? 0 and 100. Oops, I missed. You get the idea. So what's the best L? What's the best L? I'm not talking one that's pretty. What's the best L? What do you think? The best length would be one that makes what kind of rectangle? The one of the greatest area. So again, I ask, what's the best L? If L is 50, if L is 50, doesn't that yield the max area? Yeah. So the best possible case would be if you make L 50, which makes the other sides both 25. That is the best way to make the fence because that gives you the most area for your dog. Okay. Now, calculus does that in way quicker order, but that's a good start. Okay, 20, number 6. By the way, that equation doesn't need to be cleaned up. I don't care. That's fine. Okay. 20, number 6. Whoever asked that, do you still have that question, or did you have an epiphany and you're good to go?
Yeah, I do.
Okay. Now, first of all, the first two huge boxes, they were meant to agree. You were doing the same question, and they were supposed to be the same. In 26, those are two different questions, so don't expect your answers to be the same. One is symmetric to find f prime of x, and the other is symmetric to find f prime at 4. So these will not agree. F of x, if I recall, was negative 1 over x, and here we go. So in part A, do you want to do both or just one of those? Did you have a question on both?
No, just the top one.
The symmetric? Okay, sounds good. So I don't require you to write the generic definition. You can go to problem specific, but for the purposes of, the more I write something, the more I remember it. So me personally, when I first learned something, I would always write the idea first because it got into my brain quicker by writing it. So I'm going to write that. Now, if we go towards f prime, our goal is to find f prime at any old x. So this guy, the function is negative 1 over blank minus another negative 1 over blank. I typically write the shell of the function down, and then with parentheses and making sure I do the negative right, and then I say, what do I put in? So in the first space, what do I put in? X plus delta x. And in the second space, what do I put in? Minus delta x over 2 delta x. It's a bit of a mess. What algebra can I do to clear the fractions? If I multiply by both denominators, then I clear the fractions, yeah? So that's what I did. Although you could get a common denominator. Some people say, I got a common denominator. That's fine. To me, it's people then sometimes get confused as to you still have a fraction within a fraction. So this is the way I recommend. If I multiply that whole quantity, then when I distribute here, the x plus delta x goes away, and I have negative x minus delta x. Being very careful with the parentheses, because that's where the errors will happen. This guy, before I distributed, I said, oh, minus a negative, I'm going to call that positive, and the x minus x delta goes away, so that's x plus delta x. If you feel like you understand the derivative part of it, but you have an error in there, it might be because of the signs. And 2 delta x in the denominator. After that, I just have to make sure I don't screw up the signs. So it looks like the x's will drop away, negative x plus x. The delta x's do not drop away. I get 2. Sorry, I lost this. I was thinking this is not going to come out right. It's nice to have another way to get the derivative to check the answer. All right, sorry about that. So the numerator, the x's drop away. The delta x's, do they drop away or do they come out 2 delta x's? I feel like they come out 2 delta x's, which then divide away, leaving me with just that denominator multiplying factor. Excuse me. So if I substitute in a 0 there, I get 1 over x times x, and therefore the derivative is 1 over x squared. B. Okay. So you're good on the second part, are we cool? 20, number 7. Is 20 number 7 a question still? Somebody, whoever, are you still awake? Okay, cool. Do you have this down for everyone? Okay, it says. Bless you. Okay, so this is kind of my fault. I should have given you a little more note in the blocks to clarify here. So keep in mind that publication date on this is something like 1996 or something. What is this? 2002, sorry. This, my point is, this was published before the US5. Okay? So all the calculator exercises were basically working with an 84. So keep that in mind as we do some calculator problems. In 20 number 7, you're talking about this figure, which you know to be a circle, yeah? Okay. Now, here's the deal. The 84s didn't have the capability of graphing that. It's a non-function. The 84 only graph functions. So I think you'll agree that that fails the vertical line test. It's not a function. It couldn't graph. And so you had to figure out how can I put this in my calculator some other way. I will also say this. That doesn't mean this question is garbage because the Inspire can graph a circle. The Inspire can graph a circle, but there are a lot of things the Inspire wants to do that can't do in function notation. It has a hard time with intersection points. It has a hard time with area under a curve. There are a lot of calculus ideas that can't be done in the Inspire, even though it can graph this. So this is still applicable even if you have an Inspire. The point is, I want to take this into function territory, and you do that by solving for y. If I do that, I get y squared equals 9 minus x squared, and y therefore is plus or minus 9 minus x squared. Now that actually makes sense because that's two equations. This isn't one function, but it is two. When y is positive 9 minus x squared, that is the positive y's. And when y is negative 9 minus x squared, that's negatives. And so together, that circle can be made by two different functions. If you put that into your calculator, then you will, in function mode, you'll see a circle. Now the second part of the question is totally antiquated. It says, does your graph actually look like a circle? Well, when you had the 84, for whatever reason, the programmers decided to make the denominations the same both ways, although it was a rectangular window. Well, that's dumb, because if you had a circle where all sides were 10, it's a circle, but it looks like, you know, what are they thinking? The Inspire doesn't do that. It doesn't try and make the windows the same. If you look at the standard window, it's shorter here and longer here, so maybe it's negative 10 to 10 here, but only 6 to 6 there, or whatever. But the point is, when you graph it in Inspire and it says, does it look like a circle? The answer is, yeah, it looks like a circle. It doesn't look like an ellipse. And then the last question is for the 84. So I apologize. Some of these questions are annotated. Do you understand? Okay. And 20 number 16. Does somebody need 20 number 16? Okay. I'll assume you're super shy, or you figured it out, or you just said, forget it, I'll live in ignorance and move on. Yes, yes. 2017? Okay. Oh, also, question, I had a lot of questions on that. I had about 4 people come in before after school yesterday and today and ask about this, so I'm glad you asked. So, you're going to see this and think, oh yeah, that makes sense. So the question's kind of funky. It says solve for x. Now, although it seems unrelated, bear with me here. If I said solve for x, what would you do first? If you were doing this problem and solving for x, what would you do first? You what? You'd square. Why? Why not the half? Okay, so you squared because that's the inverse of square rooting. That's what gets rid of square rooting. And so when you squared, then multiplied by 2. Why did you multiply by 2? Because multiplying by 2 is the opposite of dividing by 2. So you're using inverses. Same goes here. All right, you want to get x by itself. What's the inverse of arc sine? Sine. So you're going to take the sine of both sides. And then obviously. Okay. Which, if you were to graph it, would be sweet, because it would look like this. That's really cool. Okay. I think that's it. Let me know if you have anything else. I'll be walking around. If you just want to ask me individually or ask somebody around you, that's
Oh,
you get. Hope to see you at the dash tomorrow. Better be running, you turkeys.
I'm using code, so it's just in general. Well, I'm like, are we doing a
Phenomenal 7 hours. So if you have questions, you're really motivated by it, please Hey, Pete, hop in here. Bye. Have a good day. Have a sports now. Have a good day. Bye. Thank you. Hey, Pete. Have a great weekend. Are you really? All right. Okay. Peace. Have a good weekend. Okay. Have a good weekend. Thanks. See you later. Yeah, I'll be there. I'll be at Forest Park. That way I don't have to run. What do you, what booth?
It's a pennant for marching band for raising money.
Oh, all right. How much is it?
It'll be anywhere from like $1 to $5, depending on what you get.
I want a full body.
You get something calculus related.
Okay.
You pay
It's
something.
unit circle.
Yeah, it's up to a little intervals.
Sleeve on my left arm.
Yeah.
Well, Zach, remember his unit circle tattoos he bought off Amazon?
Oh,
Yeah.
that sounds like cheating. All right. Yeah. She's kind of guarded. She's guarded. No, I wouldn't say guarded. She's all right.
Where were you?
Friday.
All right, all right. Are you ready for the easiest quiz ever?
Yes.
Yay!
Please.
Here we go. Turn your desk, please. No calculator. There is no calculator component to this. Calculators are for the weak. Brenda, how are you? Okay. Would you take a quick second and circle 3 and 6? Just the problem number 3 and 6. Those are the ones I will expect certain work. I will grade the work. All others, I will not grade the work. It will be strictly on the answer. Understood? Okay, good luck. It should not take all period. It should take about 5 to 10 minutes tops. What are you going to put in the basket? All right, finish that up, please. Uh-oh. I recorded way too long. Oh, well.